Hi, in today's video, we are going to be focusing on quadratic equations. What are they? So quadratic equations are equations that can be written in the form f of x is equal to ax to the power 2. Whenever we have to the power 2, we are dealing with quadratic equations. And if we want to write them, we can write them this way, which is a is positive, is greater than 0, or this way where a is less than 0. Okay, so quadratic equations in most of grade 12 syllabus, you either have them positive or negative. We don't mostly have cases where a is equal to 0, because if a is equal to 0, it will no longer be a quadratic equation, it will be a linear equation. So as you look at this, there's so many things we can come up with. For example, if we have our equation looking like this, this is our y, this is our x, this is our intercept. So one thing that you first you must observe is that this is a positive quadratic equation. How do we say it's positive? It's concave upwards. It's concave upwards. If you can check here, it's concave upwards. It's looking like a smile. Then you can say that, oh, this is a quadratic equation. Okay, and then one other thing that we can look at is we can also have this on the graph looking like something like this. You can also have other equations looking something like this, or it can be starting from any point like this. All right, so diving deeper into the equations, we have something like into the equations. F of x is equal to ax squared. Okay, you will remember from the previous chapters that we had equations that look like this. F of x is equal to ax squared plus bx plus c. And then if we use nature of roots, if we not nature of roots, if we complete the square, we can always write this equation as f of x is equal to ax plus or minus p squared plus q squared. This equation can be converted into this form. So this form, we will only, or will most cases use it when we are given an equation. We can be given like any graph, and then we are given these points. This point, we call it the turning point. So turning point is a point in which graph changes direction from as it goes down here. When it gets to this, it changes, it goes up. This is called the turning point. This point is also called stationary point. As the name explains itself, the graph is stationary at this point. That is to say, it's not going up or down, or it's not concave up or concave down. It's actually 0 at this point, like concave 0 here at this point. Okay, so what does this value mean? Let's say we're given a graph that looks like this. Let's say we're given a graph that looks like this, and the coordinates are 3 and 7, and then we are asked to find the equation of this graph. Let me just finish it up. Okay, looks like this. This is 0, x, and we have y, and then we are asked to find the equation of this graph. We don't know where it's going to cut the c or the y-intercept, but at some point it's going to cut the y-intercept, so never mind this part, I'm just demonstrating. So we have f of x is equal to a is going to be positive because this graph is sloping, or it's looking upwards, it's a smiley, so a is going to be positive, and we have x minus, if this value is positive, then we're going to put a minus here. So 3 squared plus. If this value is positive, we're going to put a plus 7. Okay, then after this, to find the value of a, we're going to look at the point in which this graph is going to cut the y-intercept. That point, let's say it's going to be something like 0 and 19, for example. Then we're going to substitute it here. So we're going to have 0 and 19, which will substitute at x and y. Y is going to be 19 and x is going to be 0, and then we'll be able to find the value of a, and then we'll be able to solve this equation. After solving, you can also convert it into this form. After solving, which is f of x is equal to a x squared plus bx plus c. Okay, sometimes you'll be given the intercepts. When you're given the intercepts, use this formula: x minus root 1, this is r1 here, into x minus root 2. Okay, and then the graph can look something like this, and then you're given this value as well as this value. This is your y, this is your x. Given these two values, let's say this value is gonna be 0 and 2, then this one is 0 and 4. Okay, so when you're given this graph that has only the x-intercepts and not the turning points, we can use this formula like I said. And then how you use it is you're just gonna say f of x is equal to a is gonna be positive, so we will find it after substituting this value. So we know we have these coordinates are not correct, sorry. So it's gonna be 2 and 0, and it's gonna be 4 and 0, because we are dealing with the x-intercepts. Okay, so we know that x minus 2, remember it's positive, so it's going to be minus, and then x minus 4, x, which is the given x, r1 is this first value, r2 is the second root, so it's going to be 4 minus 4. And then to find the value of y, we're going to look for the third value, which is going to be the point in which this graph will cut the y-intercept, and then it will help us find the value of a, which should be positive by all means. So let's say this graph cuts the y-intercept at 3 and 0, then we're going to substitute 3 here and say our y is equal to 3, and then our x will be 0, so it's going to be a 0 minus 2, 0 minus 4, and then 3 is equal to 0 minus 2 times 0 minus 4 is going to be 8 a, and then we know that our a is going to be 3 over 8, which is positive. So going back, we will have f of x is equal to 3 over 8 x minus 2 x minus 4. Then we are done. Okay, so for revision, we have 3 situations that we spoke about. We have 3 situations. One, we are given the turning points. 2, we're given the intercepts, x-intercepts. Okay, and then when we're given the turning points, we use this formula: f of x is equal to a. When we're given the turning points, you use x plus or minus p squared plus q. When we're given the x-intercept to use, is equal to ax minus root 1 x minus root 2. Okay, and then the other instances is where our graph does not cut at any point on the y-intercept, such that f of x is just going to be ax cubed, where like it does not cut, it can cut the y-intercept but not at any point. It's just at the origin, not cut the, or rather put it this way, cut the y-intercept at origin. At the origin. This is case number 3, where our graph can be like this. Observe, it can only cut here or here. That's why we have y is equal to x to the power 2. Sorry, this is x to the power 2. Okay, so this is case number 3. It cuts the y-intercept at the origin. And then case number 2, our graph, we're given only x-intercepts to find the equation of our graph, and point case number 1, we're given the turning points to find the equation of our graph.